Alright, hello guys, welcome to the first installment of Chan Academy for Math 1. I just want to go over a couple things while I was gone, and some of the things that you guys had trouble with, so I wanted to do this video to kind of clarify that, as well as kind of go into like what we are going to start doing today and work on. So just to start off with this is, I'll start off with a joke, okay? So who invented algebra? A clever expert. Haha. Alright, and then the other one would be, what do you call a good group of friends who like math? Algebros. Alright, so they're my funny jokes, but I guess they're really not that funny. So, I wanted to show you guys how to find my website, and you just go to sphstigers.org, go to classes and homework. From there you type in Chan, you'll find me right there. And then I have all this stuff, advanced algebra stuff, you guys, all class resources, and then I have my Chan Academy channel up on here, remind, text alert, message things, and then all of your class homework should be in here. So you can pull up something like this, and you can see this. Right? And I haven't updated it yet. I'll do after this video. So I'm going to pull up a problem that I think you guys might have had trouble with, so I'm going to do this one. Okay, so it says the People's Republic of China is the country with the largest population in the world. The population in China in 2011 was approximately 1.3 billion. So I'm going to start off by filling this as 2011, and the total population was 1.3 billion people. Okay, and I'm actually going to write it all out the correct way. 1.3 billion people is okay, so hundreds, thousands, millions, 1.3 billion. Okay, all right, so what I need to do is I need to calculate. So let me just keep going here. Although families are encouraged to have only one child, the population is still growing at about a rate of 0.5% per year. Okay, so obviously in 2011 there should be no change, right? They told us the population in 2011 was 1,300,000,000. Okay, so we want to find the next year and 4 more years after that. Okay, and that's for A. Estimate the population of China for each of the next 5 years and record your estimates in a data table. Alright, so the way I'm going to do this homework is it's a really short homework. All you need to do is just copy exactly as I write on this thing, and that way I just know that you have something. Okay, I'm going to go over this, and I'm also going to go over one of the rule ones. Okay, so 2012. So I'm going to put the population, and this is typically how it's going to work, right? If I have 1,300,000,000 people and I want to find the change from one year to the next, I just take 1,300,000,000, and I multiply by the percent change, which is 0.5%. That's really 0.005, right? And if you can't remember how to do percents to decimals, look it up on Google. I don't want to take the time to talk about that, but it should be something that you should know how to do. Right, so from here we get that our change is 6,500,000. Okay, alright, so that sounds right. Alright, 6,500,000. Okay, so that's our change, right? Now, we have to add that on top of the total population. So we're going to add that with the total population. 1,300,000,123,123. And that should give me 1,306,500,000. Okay, so I found my first year of change. Okay, now I'm going to take the next year change. Okay, but am I still thinking about 2011? No, now I'm at 2012. So I want to find the difference from 2012 to 2013. So I can't keep talking about the same population that was from 2011. Now I'm looking at from 2012 to 2013. And the way I'm going to calculate that is I'm going to take the population from 2012, this one, and I should probably do that in red, 2012, and I'm going to multiply by this 0.5% again, and that'll give me my new change. So now I want to look for 2013. So I'm going to go ahead and do the calculations. 13065000123 times 650. Oops, what am I doing? All right, 13065000123 times 0.005, and that's for the 0.5%. All right, that gives me a change of 6 million. Change it back to no, let's keep it right. 6,532,500. All right, so I found my change now. All right, now all I have to do again is go ahead and add this to the population from 2012, and that'll give me my new population for 2013. So I'm going to add this with 13065000123, and that's going to give me 1,313,000,000 and 32,500. Okay, now to calculate the next one, I would just take this population again, multiply by 0.05, and do it again, right? So I'll change it to green, and this time I'll just save some time. 2014. I'll just do the change, and then I'll leave it alone. So I'm going to take 13130325000 times 0.005, and that's going to give me my change. Now it's 6,565,162.5. Okay, so it's a constant like iteration, right? And what I wanted you guys to see is that it's increasing, but it's not exactly the same increase every time. You're not going to increase by 6,500,000 every time. It's going to continually become more and more of a change as the population continues to grow, right? If you got 1% interest on $1, that's not a lot. If you got 1% interest on $1 billion, that would be a decent amount, right? So over time, this thing gets bigger and bigger, right? All right, so I want to talk about the now next rule, and it's typically like this. So using the word now to stand for the population in any year, write rules that show how to calculate the population in the next year. 1, if the growth rate stays at 0.5%. So to do a now next rule, I'll do this. To me, it's a little important, but as we get further on in the year, you're not going to need this now next thing. It mostly just becomes some algebra stuff. Okay, so the now next rule will look like this. Now the population now will increase each year by multiplying by 0.5%. I'll put 0.5% or 0.005, and it actually was also known as 0.005. Then adding to the current population. So you're just trying to come up with a way to say what we did. So the population now, as in like this one, 1.3 billion, multiply by 0.005, and then adding to the current population will give me the next year's population. So this now next rule stuff really just is a way for you to write out what you're thinking already, is that you take the population, you multiply by 0.05%, and then later you add it onto the old population, and that'll give you your new population. So use the words now and next. Okay, so the next thing I'm going to do is I'm going to pull up a couple problems for you guys to do. So I'm going to pause my recording and then switch it over to a different slide. Alright, so let's talk about these rule things. Essentially, we're coming up with two of the variables, which a lot of times in the ones that I've been making, like for the start, is I'm giving you the variable essentially, and then you have to figure out which one's dependent and which one's independent. Okay, so let's look at the first one. Mr. Blackford has, and I want you guys to write these down. Okay, so Mr. Blackford has $1,000 to give away, and so he is giving all students who have an A in Math 1 an equal portion of the $1,000. Write a rule for the amount of students' earnings and the total number of students. Okay, so we want to think about which one is the independent variable and which one's the dependent variable. So I'm taking a look here, and it says students' earnings and the total number of students. Okay, so Mr. Blackford has $1,000 and he's going to give it away to the students, and it really depends on how many students there are. Okay, so I said the word depends. Okay, so what depends on what? Well, the amount that a student earns depends on the total number of students. So I know my dependent is equal to the amount, A, right, which it said for me right here. And then my independent is going to be S for students, right? Because the amount that a student earns depends on the independent, right? Which depends on the number of students, and that should be an S. It doesn't look very pretty. Okay. All right. So what I'm gonna do is I'm gonna make a rule for it. So the dependent is typically on its own, right? The amount a student earns is just on its own. So the dependent A is equal to, has $1,000 to give away, and what I'm trying to do is I'm trying to model like thinking it through. Okay, so $1,000 to give away, and he's giving all students in Math 1 an equal portion of the $1,000. So in other words, let's think about it this way: if there's one person, that would be $1,000, right? Okay. Two people would be $500. Three people, well, how am I getting these things? I'm getting 1,000 divided by 1 is one person, 1,000 divided by 2, that's going to be 500 each. 1,000 divided by 3, that's going to be 333 and 33 cents each. For 4 people, I'm going to get 250. Okay, what kind of rule am I making here? Because in my head, I already know intuitively what it looks like. But I have $1,000, and I seem to be splitting it by the number of people there are, right? If I had $1,000, one person would get 1,000, 2 people would get 500, 3 would get 333, 4 people would get 250. Somehow I already know what the answers are, but it looks like if I have S here, oh gosh, I can't do an S. Alright, if I get an S here, just believe me that that's an S, it seems to work out. So I think this is it. So if I plugged in something like 5, and that's supposed to be an S by the way, I would get 200 each, and 1,000 divided by 5 is 200. So this is the correct answer, okay? 1,000 divided by S. Now here's one that's near and dear to you guys, because it's something that you guys seem to hate about my room, is how cold it is. So the temperature in Mr. Chan's room is 68 degrees Fahrenheit, okay? For each person inside Mr. Chan's room breathing hot air, the temperature in my room increases by 0.5 degrees. Write a rule for the temperature in Mr. Chan's room, so temperature in Mr. Chan's room, and the number of students. Okay, so I'm gonna leave this one up to you guys, right? And I'm the only thing I'm gonna do is I'm gonna do this for you, is that the temperature in my classroom depends on the number of students. So I know that this one is dependent and this one is independent. Okay. Now, the only homework you have, other than to finish watching this video, which if you're at the end, you have, is to finish this problem. Okay, so I think you guys can do it. Otherwise, come back to class with questions. And this ultimately leads me to where you guys are going to be better than my advanced algebra class, is these word problems. You guys are able to figure out what the variables are and how to set up the rule. So if you guys are able to do this, you guys will be in very, very good shape compared to even some of my older students. So I hope you guys enjoyed the video. I know that I try not to make these too long. They always stop at about 15 minutes. So just please do this. Remember, you're supposed to write down everything that happened in this video, and the only homework is this problem. So have a good weekend, guys. See you guys.